It says use proof by contradiction to prove that the curve of equation y equals 2x plus x plus cos x has no stationary points for 4 marks. Remember, we are always starting with an assumption, right? We want to assume the negation of this statement. Can somebody tell me what the negation of the statement would be? Exactly, Khalil. Fantastic. It has no stationary points. Well, opposite of that, it has stationary points. So you're going to say, assume that y equals 2x plus x cubed plus cos x has stationary points. Stationary points, right? And then it's our job to show in our algebra that that can't be possible, right? Now, stationary points, guys, what does that mean? What does that mean when you see stationary points? Fantastic, Sophie. Fantastic, Raheem, right? It just means that dy dx is equal to zero, right? So essentially, when you're doing these types of questions, you're going to say, okay, well, fine, because it's a proof by contradiction question, maybe I get dy dx set equal to zero. I know that that has to have some issues. That actual equation itself must have some issues. So we've got y, right? We've got y is equal to 2x plus x cubed plus cos x. Now, let's do it bit by bit. Dy dx, right? Because somebody told me very quickly the first term. What do we get? We differentiate 2x, guys. Fantastic, guys. Well done. We get 2. Next term, guys. What do we get? Brilliant, guys. Fantastic. We get 3x squared. Thank you very much, Kilo. Right? Now, how do we differentiate cos, guys? Remember we did this last week. Anybody remember? Fantastic, Kilo. Well done. Fantastic. So if remember what we did last week, SC minus S minus C. You go down, you differentiate. You go up to integrate. So because we want to differentiate cosine, cosine is here. We go down one to minus S. So it differentiates to minus sine X. Is everybody happy with that? Yeah, good stuff. Brilliant. So this must equal zero. Now, are there any problems with this? Well, let's investigate. Well, firstly, what I would do just a bit of algebra, this here is a polynomial, right? This is a trigonometric expression. I'm going to isolate that. So if I move that over, then it becomes sine x is equal to, and then I'll just swap these over, 3x squared plus 2. Is everybody happy with that? Yeah. Now, are there any issues with this? Remember, it's a proof by contradiction question. So you know that the algebra must not hold somewhere. There must be an issue. Is there an issue with this at all, guys? Think about your graphs, right? Having a really good understanding of your graphs, what they look like, knowledge of your graphs is super, super important in all types of areas of maths. Any problems, guys? When you say it doesn't match up, what does that mean, right? Well, let's draw it, right? Let's draw sine x, for example. We know that sine x, where's my graph over here, right? We know that the graph of y equals sine x, y equals sine x, right? Oscillates between 1 and minus 1, doesn't it? Goes like this. Whoops, what happened there? Like that. This is 1. Why is that happening? 1 and minus 1. Everybody happy with that? Yeah? Good stuff for him. Exactly. How about 3x squared plus 2? What about 3x squared plus 2? Let's draw another one. 3x squared plus 2. Graph transformations. Well, y equals x squared is like that. 3x squared does not change the minimum value because it's at 0. It stretches it vertically by 3 units. So essentially, it's going to look something like this. It's going to look something like, it's going to just stretch up like that, really, right? But the minimum point is still going to be 0. This is y equals 3x squared at the moment. What does the plus do to the graph? What does the plus 2 do to that graph? This is currently y equals 3x squared. What does the plus 2 do? Exactly. It shifts it vertically up by 2 units, right? So let's just say it's like that. And let's just say it's like that. Remember, it's a sketch, doesn't matter. But the most important thing, guys, is that the minimum point, right, is what? What's the minimum y value here? Exactly. It's 0 minus 0, 2, sorry. So what I can say from there then is that for this one, sine x ranges between -1 and 1, right? This one, 3x squared plus 2, right, is greater than or equal to 2. These can't match up, can't can they? Because if I was to put them on the same graph like that, whoa, let me draw a bit neater. That's not good. Hold on, guys. Let me get a line like that. Then essentially be like this. Be like that. Be like that. Whoops. It'd be like that. That is 1. That's -1. The quadratic is up there. That's 2. It's like that. Right? They never intersect. Sine x and 3x squared plus 2 never intersect. So therefore, sine x is never equal to 3x squared plus 2. Is this a contradiction to anything that we've done? Absolutely, because when we said dy dx is equal to 0, we got to the fact that sine x is equal to 3x squared plus 2. So what you're going to say here is that this is a contradiction. This is a contradiction. As we stated, sine x is equal to 3x squared plus 2. So we found our contradiction. And then what do you do now? You just summarize, right? What was the proof ask us to do? Use proof of contradiction to show that to prove that the curve y equals 2x plus x cubed plus cos x has no stationary points. So therefore, we can say y equals 2x plus x cubed plus cos x has no stationary points. And that is it.